Hello and welcome to Ag United. This is the lecture number 2 on robotics engineering series. In this lecture, we will going to discuss about classification of robots. The first classification is based on the degree of freedom. On the basis of degree of freedom, the robots may be classified as general purpose robot, redundant robot, and deficient robot. The question is, what is degree of freedom? So the degree of freedom is defined as number of motion can be performed by a body in a space. In the Cartesian coordinate system, the space is defined by a three mutually perpendicular planes, which is separated by three mutually perpendicular axes, x, y, and z. The body can translate and rotate about a x-axis. Similarly, the body can translate and rotate about a y-axis as well as z-axis. So the total number of motion done by the body in this space is 6. So we can say the body having 6 degree of freedom in the space. On the basis of this, the general purpose robot have 6 degree of freedom. Redundant robot have degree of freedom greater than 6, and deficient robot having degree of freedom less than 6. The second classification is based on the kinematic structure. The first one is open loop structure. The structure takes the form of an open loop chain. It's called an open loop structure. The example of open loop structure is this. This is the base. This is the link number 1. Is a joint, and this is the link number 2. And here is we provided some end effector. So this is the open loop or a serial manipulator. Closed loop or a parallel manipulator is made of a closed loop chain. Here's the example is a delta robot. Delta robot is like this. Here is a gripper or a end effector, and this is the link connected to the gripper. This is a closed loop chain called a delta robot. And third one is a hybrid manipulator. It consists of both open and closed loop chain. Fanuc S900W is the example. Next classification is based on the drive technology. Drive technology, that means the power source of manipulator to drive the robotic system. The robotic manipulator may be driven by electric energy or hydraulic energy or a pneumatic energy. Next classification is based on the workspace geometry. On the basis of the workspace geometry, the robotic system is classified as a reachable workspace or a dexterous workspace. The reachable workspace is defined as the volume whereby the end effector can reach each point within the space at least one orientation, while the dexterous workspace has the end effector capable of reaching all points in all orientation. Here is the difference between the reachable workspace and dexterous workspace. Here are some example of robotic system based on the workspace geometry. First one is a Cartesian robot. In this robotic system, the link of robot perform translatory motion along a x-axis, y-axis, and z-axis. Here are the three axes, say x, y, and z, and all the links can perform only translatory motion along this axis. The example of a Cartesian robot is a gantry robot. The second is cylindrical robot. In this robot system, is a coordinate frame. This is a z-axis, this is a x-axis, and this is the y-axis. The link one is rotated about a z-axis and can translate about a y and x-axis. This type of arrangement is called a cylindrical robot. Next is a spherical robot. In this system, in a Cartesian space, in a spherical robot, here is a coordinate frame, and this spherical robot, the robotic link may rotate about a axis 1 and also rotate about a axis 2, and link 3 translate along the third axis. So here the link, here we have a 2 rotation axis and 1 translatory axis. This type of arrangement comes is known as a spherical robot. Next is the articulated robot. This is the schematic view of an articulated robot. Here is the coordinate frame. This is the coordinate frame, say X, Y, and Z axis. The robotic links can rotate about a axis 1, axis 2, and axis 3. This type of arrangement is called a articulated robot. And this type of robotic system is generally used for welding purpose or painting purpose. Puma robot is one of the example of the articulated robot. Next one is a SCARA robot. SCARA stands for the Selective Compliance Assembly Robot. This is a special type of robotic arrangement. In this robotic system, we have a 2 rotation about 2 axis, and we have a linear motion. This robot generally used for the assembly purposes. We have seen SCARA robot on a assembly line. Thanks for watching.